Question 62 is a little bit of an upgrade on what we have been doing so far, because in this case they are not asking us to find tension anymore. What they want us to do is to figure out the maximum mass of this physics shop sign that we can hang from the beam, which is supported by the cable. So the beam and the sign will be supported by the cable, and they give us the maximum tension in the cable. So I'm going to draw it right here. There are two ways to approach this. You can split the mass in two for the sign and get your two different torques. But since the sign is, but we can also assume that the sign is a uniform shape, meaning that its force of gravity will be applied at the center of gravity, which will be smack in the middle. That makes it way easier. I mean, you're welcome to check that G times half of mass times 0.8, if we consider it applied right here, plus another half of mass times, if I'm talking about this one, so this would be times 2, and that equals G times 0.8 divided by 2 is 0.4 mass plus 1, because 2 over 2 is 1 mass, so that's 1.4 mass times G, which is the torque. Okay, so that's just way easier. So just assume that the center of gravity is where your torque is applied, or your force rather, is applied, and go from there. So then I also have the weight of the actual beam itself, which is 1 meter away from this axis of rotation. So let's write it out. Our torque clockwise comes from, I'm going to factor out G times 5 times 1 plus, and the mass that we do not know, times 1.4. That would be the torque of tension times the lever arm of tension. Now, the lever arm of tension is a little bit iffy here. So I know that this will be my lever arm, right? And I know I will need this angle. They're not giving it to me, but they give me this big triangle of the cable and the beam itself. So if I want to find the angle right here, I can just do inverse or arctan of 2.5 over 200. I mean 2.5 over 2, which is 250 over 200. That is 51 degrees. And then to figure out my lever arm, which is right here, I would do 2 times sine, because that's a cross, right? Times sine of that 51 degree angle. I got 5 times 9.8, so that's a 49, plus 1.4 times G, 1372. 1372 times mass equals, force of tension is 300 reportedly, times 2 sine of 51 degrees. Then from there, mass is going to be the 600 sines of 51 degrees minus 49 all over 1372. That gets me 30.4 kilograms. Depending upon rounding, I could have done sine of 10 of 2.5 over 2. That would have been the best practice. If you can handle that in your calculator, then that would reduce all the rounding. But I mean, this answer is close enough.